Okay, this one, you definitely have to use the calculator. That is crazy. For those of you who cannot see what this looks like in the back, y equals x over square root x squared plus 1. Please don't integrate with your hand. When it says use calculator, use calculator. I know your use sub skills are superb, but don't use the do it by hand if you don't have to. Okay, first graph both. So maybe make this y1, make this y2. And yesterday I showed you how to write fractions on your calculator. That way you don't have to go through a lot of parentheses. If you want me to show you the fraction button again, I can. Okay, so graph those two. There are 2 points where they intersect, and it does switch over. So you're going to, no, this one doesn't switch over. This one is just one big graph intersecting at 2 points. One is on top of the other, and it's very clear. And all you have to do is just integrate, but the calculator practice. If you're stuck, let me know. Okay, so the area is equal to 0.785. Okay? Yes. Okay. Next one. Should we do this one? Let me double check if there's a, oh, this one's much better. I like this one. Okay, let me write it out for people in the back. y1 is equal to cosine x. y2 is x plus 2 sine to the fourth x. You have to figure out how to type in sine to the fourth on your calculator, okay? So I showed you that before, but if you forget, let me know. They do switch somewhere in the middle. So you have to figure out where that is on your calculator, with your calculator, and then you have to write two integrals and integrate. The fourth, so what you want to do is just type sine x. It's going to look like this. Another parentheses, and then put fourth. Okay, so use your calculator. They do intersect in 3 places, and they will switch, swap directions. Okay, I'm going to give you the integral part, so you can double check to see if your limits are correct. Negative 1.912, always 3 decimal digits. Negative 1.224 of x plus 2 sine to the fourth x minus cosine x dx plus integral from negative 1.224 to 0.608 of cosine x minus x plus 2 sine to the fourth x dx. Okay, the answer is 1.704. Okay, make sure you have 3 decimal digits. You can't have more than 3. Yeah, you can have more than 3. It just has to be at least 3. Okay, that's it for today. All right, so you guys all watched the video on the WSQ, so you know that we are going to go in the y direction, which everybody got. Okay, so we've been talking for 2 days about how to find the area between 2 curves. We talked about 2 different cases so far. One is that you have a graph like this, where it's very apparent which one is on top of the other. The other case is you have something like this, where they swap direction from one area to the other. So those are the 2 cases. But both of them are going in this x direction, so it's easy to do. This time we are going to look at this area. Looks like this. The curve is in terms of x and y. So what you could do is you could still look at top minus bottom, but it's not apparent because here, right here, it's on top of each other. So, you know, that doesn't make any sense. You're taking a curve minus itself and integrating on x, or this part, it is the line D minus the curve, and then here it is the line minus the blue line. So that doesn't make any sense. If you do, you know, you want to integrate like that, you will have to create so many different area sections. So it's much easier if we go in the y direction. That means we're going to go this way. Okay, so if you're not really sure how to do it, just flip your graph like this. You're still going in the x direction, top minus bottom. Oh, are you guys good? So just like tilt your head. It's going to be from the right to the left because that's where the positive numbers are. More positive, less positive, so you're going right to left. So the right curve minus the left curve, okay? So that is kind of the key. Sometimes people forget. It's easier to think top minus bottom. It's harder to think right minus left. So right curve minus left curve. Okay, now the question is, how do you integrate? You always, again, integrate from the smaller number to the bigger number. So you're going to start with C and go to D. So the smaller y to the bigger y. Okay? So tilt your head and look from the right to the left, but then we're still integrating from lower y value to higher y value. So this one, we would write the area is from C to D of f of y minus g of y. Remember, you're now integrating in y, so make sure you write dy and not dx. Okay. All right. Let's look at one question together. Find the area of the region enclosed by the graphs of the lines y equals x minus 1 and the parabola y squared equals 2x plus 6. Okay. You probably forgot how to graph in terms of x instead of y. Okay, so how do you know when you're going to pick x and when you're going to pick y? Okay, this line. Line doesn't really matter. It is just a straight line, so that doesn't really tell us we have to pick y. But let's look at this one. Y squared equals 2x plus y. When the square is on y, we know that this parabola is going to go left and right. Left and right. Okay, when it's an x squared, we know it's going to go up and down. Okay, so this is going to be a parabola that goes left and right. So let's just graph it and see how that looks like. Y equals x minus 1. That is a y-intercept at -1, and then it just looks like this. Y squared equals 2x plus 6. Y squared equals 2x plus 6. We know it's going to be a left and right graph, parabola. We don't really know how it looks like. So let's go ahead and solve it in x. So y squared equals 2x plus 6. So let's solve it in x. Let's divide by 2. So that is y squared minus 6 over 2 equals x. Let's simplify this some more so it looks like a standard form or a vertex form. X equals 1/2 y squared minus 3. Okay, so it is a parabola with a left 3 and then a shrink by 2 or compressed by 1/2. The reason that it is going left 3 and not down 3 is that we are going left and right this time. So it's a left and right graph, so the direction is all switched. If you still remember last year, we went through a whole chapter of conic section and we did like left and right parabolas. We had like ellipses and circles and all that stuff. So that's what happens. Okay, so we're going left 3, and then this is going to go towards the right because it's positive. So it looks like that. I don't know where it intersects yet, but I know it's going to intersect somewhere. Okay, so we want to find this region. Now, if you look at it, you can see that it is not easy to integrate in terms of x because when you look straight down, you're going to cut through itself, and then there are places where it goes through both curves, but not always. So it's much easier if you go left to right, okay, in terms of y. All right, so that means we need to figure out where these two intersecting points are. And how do we do that? Make them equal to each other. Okay, when you make them equal to each other, I'm not sure how you guys want to do it. You have many different ways. You can do substitution in terms of x or in terms of y. Do you guys need me to help you, or you can solve it? Yeah. Yes. Yes, what? Oh, okay. Okay, y is equal to x minus 1. Y squared is 2x plus 6. So y is x plus minus 1 is the new y. That's equal to 2x plus 6. Okay? Actually, that's not a good idea.
Can we do like y plus 1 equals x?
Yeah. Okay, so the reason being we are solving for y because we're going to integrate in terms of y. So it's easier if I solve in terms of y first instead of y. Just save myself some time. Okay, so let's change this. Change this to x equals y plus 1. And I already have the equation in terms of x for parabola. I just need to make them equal to each other. So y plus 1 is equal to 1/2 y squared minus 3. Obviously, you should get 2 y's because you're intersecting at 2 places. Okay, so go ahead and solve for y. Okay, what y values did you guys get? 1 and negative 2?
No. Negative 2 and 4.
Negative 2 and 4.
Oh, yeah.
Okay, so that means this point is negative 2 and this point is 4. All right, so now let's integrate. Negative 2 to 4 of which one minus which one? Let's see. We are going from the right to the left. So which curve minus which curve?
X minus 1 minus... Oh.
No. We are integrating in terms of y, not x. Okay, y plus 1 minus which curve?
The red one.
The red one. What is the equation?
Y squared minus 6 over 2.
Ooh, no. Wait, y squared? No.
1/2 y squared minus 3.
Oh, sorry. Yes, you're right. Y squared minus 6 over 2. Or 1/2 y squared minus 3. Okay, so both of them are okay. And then we're integrating in terms of y. Okay, so go ahead and do that. The answer is 18. Okay, so if you're not sure how to do it, I can help you later, but that's an integral question, so we're gonna just assume that you remember how to do the integrals. Okay, next one. This one's easier, and this one has a trick. When you draw this kind of picture, if there is an apparent symmetry, please just do half of it and then double. Don't do the entire thing because you're just kind of wasting a lot of time integrating. Okay, so go ahead and draw this curve, y squared plus 1. Remember, you're now a left and right parabola. That plus 1 means go to the right one, not left one, okay? Y squared plus 1, and then x equals 5, y equals negative 3, y equals 3. Find the area. Okay, so x equals y squared plus 1. That is a parabola that is moved to right one. So that is like this. X equals 5, so somewhere here. Y equals negative 3, and y equals 3. So you are looking for this area. Okay, notice that this is symmetrical. This parabola obviously is symmetrical because it's on the x-axis, symmetric with the x-axis. So that means these two areas, the red and the blue, are exactly the same. So when you integrate, just integrate half of it instead of the entire thing, and then double. That way it saves you time. Are you guys okay? Yeah, okay, so this is negative 3, this is 0, this is 3. So integrate just from 0 to 3 and then double that. Okay, so we are going from the right to the left. So this integral is from negative 3 to 3 of the right curve, which is 5, minus the curve in terms of x. I'm sorry, in terms of y. Y squared plus 1. dy. Okay, we're integrating in terms of y, so it's going to be dy. Now, this is, since this curve is symmetrical, we can just say it's 2 times 0 to 3 of 5 minus y squared plus 1 dy. It just helps you integrate a little bit faster because the second part is 0, so you can kind of ignore the second part of the evaluation. Okay, either way, the answer is 6. All right, let's go ahead and look at the next kind. Ah, darn, I forgot to upload it. Okay, let me write it here. Okay, find the area enclosed by the function y equals 2 minus x, y equals square root x, and y equals x squared over 4 minus 1. Okay, this is the case where we have 3 curves, and this is going to be tricky. Okay, so let's draw this out for you. First one, y equals 2 minus x. That means the y-intercept is at 2, and then it's a downward slope. So like this, y equals 2 minus x. Second one, y equals square root x. That's this one. Third one, y equals x squared over 4 minus 1. So that is down 1 and then compressed by 4. Down 1 compressed by 4. I think, oh, I'm drawing this wrong. Okay, so how does this curve look like and what do they want us to do? Am I doing this right? Yes. Okay, so they want us to figure out the area here. Yes.
Why isn't it where the black line and the red line intersects at the top?
It
Like,
just,
I mean,
huh?
why it can be like this part?
I'm just drawing out what it really should be, like so you don't have to figure it out later. That's where they intersect.
Okay, so there's not another intersect for the black and red line?
There is, but it doesn't matter. It doesn't intersect with the red line. We are trying to figure out where all 3 intersect. Okay, so talk to your partner. Are you going to integrate in terms of x, or are you going to integrate in terms of y? And y. And if you're going to integrate in terms of x, how are you going to do it? Okay, how many people are going to integrate in terms of x? Raise your hand. How many people are going to integrate in terms of y? Okay, how many people say that it doesn't really matter? Okay, yeah, it doesn't really matter for this one. Why? Because either way, this curve is not easy to integrate. Okay, so you can see, there's just no easy way. Okay, you can see that if we integrate in terms of x, we're going to go straight down like this, right? So it's going to be the red minus the black. Now, when we get to this part, it's going to be the blue minus the black. Can you guys see that? We're not in the red zone anymore. Okay, now if you integrate in terms of y, it's going to be the blue minus the red, and then on the bottom is the black minus the y-axis. Either way, you're going to have to do it twice. So in this kind of curve where you have a very interesting shape that is composed with many curves, you need to cut the curve. So I'm going to integrate in terms of x because that's how I did it. Okay, so you're going to cut it in half where the curve swaps. And then you are going to figure out this part by itself, and then you're going to figure out this part by itself. Okay, obviously you need to know where this point is. And how are you going to do that? Ooh, no. Make them equal to each other. So make the 2 curves equal to each other. 2 minus x is equal to square root x. And then we need to figure out where they intersect. And according to this graph, there should only be 1 point. Do you guys remember how to do a square root? Square both sides. Yeah, so that's going to be 4 minus 4x plus x squared equals x. And then solve that. Okay, what you guys get for x? Huh? 1. Okay, so this point is x equals 1. Okay, a lot of times when you are solving, just be careful. Sometimes you solve for x and you're actually integrating in terms of y. You got to find y, okay? Just kind of be careful of what you're doing. Okay, so the first curve, the green one, I'm going to write this in green, is from 0 to 1 of the red curve minus the black one. And this is dx plus the integral. Oh, okay.
Why is it 0?